What's up, guys? Welcome back. I'm back streaming. We're gonna start off with a LeetCode problem. What's up, guys? Welcome back. Added, yeah, dude. What's up, bro? Good to see you, my guy. How did your Amazon stuff go? Added, yeah. How did your Amazon interview go, bro? Yo, what's up? How's the job going? I don't start till January 5th, bro. I'm still in school. I'm still in university. I graduate in December. But yeah, it's I start January 5th. So just kind of relaxing. Okay, so we're given a times 10 integer matrix grid where each value grid ij represents the evaluation point ij. It starts raining and water gradually rises over time. At time t, the water level is t, meaning any cell with a... I haven't got my rescheduled date yet for Amazon. Oh shit. Okay. Hello again, dude. What's up, guys? Holy shit, there's so many people on the stream. What's up, guys? It's crazy. Usually no one really... Kendrick, dude, what's up, bro? Squirrix. No one really joins. It takes a little bit for people to join. Appreciate you guys being here. Then we're gonna start off doing this LeetCode problem, and then I'm gonna work on the restaurant management system for my class. So I've decided, I think I've said this on stream before, but I've decided what I'm gonna do is, so I have the thumbnails together for the future streams. I think what I'm gonna do is I'm gonna finish that 2D game, which I think we're really close. I'm gonna work on it a little bit more tonight and pump out some more stuff. And I'm gonna do a 3D development series with C++. So we're gonna build a 3D game, and I'm gonna live stream every single part of it, like from literally me creating the project to however long it takes for me to finish it. Hopefully a couple months. I mean, maybe around the time that I begin working in January. Hopefully that's probably around the time we'll finish. I got a lot of time off coming up, so you know, we got like Thanksgiving coming up and a lot of breaks, and I'm not gonna be going to see my girlfriend. Was going to sleep and saw your stream. Let's go at it, yeah, let's go, dude. We're gonna solve this problem, bro. Have you solved this problem today, dude? The daily problem? But yeah, that's what I plan to do. So do a 3D development series, and we're gonna build a 3D game. I don't know exactly what. I've never done any 3D development, but I was thinking of kind of trying to make Minecraft or something. I don't know, like figuring out just how to render a block to the screen, right? Or render, you know, a square to the screen to start with. I mean, we have to start even more basic, right? And then try and get a camera movement around it 3D, maybe try to load some textures, and then try and do chunk loading or something. I don't know. Like, we'll figure it out, but, you know, again, I don't know anything about 3D development, so, but, you know, doing something like that, I don't know. Just something fun, something to learn. You know, I'm interested in 3D development, so never done anything like it before, but I think that's the plan. I got the thumbnail together. So as soon as I'm done with the 2D game, I think that's what we're going to do. And hopefully I'm going to try and finish it like the 2D game in the next couple of weeks. Hopefully, I think. That's the plan. I want to finish it though. Anyway, let's finish with this. It starts raining. Water gradually rises over time. At t, the water level at the water level is t, meaning any cell elevation less than or equal to t is submerged or unreachable or reachable. You can swim from a square to another 4-directionally adjacent square if and only if the elevation of both squares individually are at most t. You can swim infinite distances in 0 time. Of course, you must stay within the boundaries of the grid during your swim. Turn the minimum time until you can reach the bottom right square if you start at the top left square. Okay, so we start at the top left square. Never tried this. Yeah, bro. Let's try it right now, dude. Before you go to bed, bro. Let's race, bro. Let's race. joking, bro. You'd probably beat me, low key. I think so slow, dude. I have to read it again. I'm that slow. So when the n times n integer matrix grid ij represents the elevation point at ij. Okay, the elevation point at ij. So we're at 0 here. 3, I assume, is the most, right? It starts raining and water gradually rises over time. At time t, okay, the water level is t, meaning any cell with elevation less than or equal to t is submerged or reachable. You can swim from another square to a 4 directionally adjacent square if and only if the elevation of both squares individually are at most t. I think a binary search would work. I don't know. I'm not thinking that it's binary search. I think it's more BFS or DFS or something. Because we have to get to a certain location to the bottom here. Right? So, trying to think. I'm a little confused to what T exactly is. That's what I'm confused about. It starts raining. Like, we're not given a T. Maybe I might ask Claude for a better description. Oh, no, I don't want all this. I just want the title. Can you give me a better description? No code. Let's see. Oh, I got 1. Okay, never mind, I did it. Okay, yep. These numbers represent the elevation height of that cell. You start at the top left corner, and you want to get to the bottom right. Yes. At any point in time t, the water level rises to height t. At any point in time t, the water level rises to height t. You can only visit cells with elevation less than or equal to t. Find the minimum t required to reach the destination. In other words, what's the minimum water level needed so that there exists a valid path from start to finish? Initially, time is 0. Only cells with elevation 0 are accessible. As time increases, more cells become submerged and accessible. At time t, only cell 0 is accessible. At time t is equal to 1, cells 0, 0, and 1, 0 are accessible, but still can't reach destination. At time t, but still blocked. At time t is equal to 3, all cells accessible can reach the destination. A similar question came in Leetcode contest as the last question. Yeah, dude, the only thing that's confused me about this question is the t part of this question. I don't really understand. Like, we start at time t 0, and what, after every iteration, it like after every iteration it increases. This is common part of the point of the confusion. T is not about the iteration of steps. T is not a counter. Okay, T represents the water level threshold. Constant water level for your entire journey. You pick a value T, say T is 5. Water is at level 5 for the entire time you're swimming. Okay. Damn, bro. When we start at T is equal to 0, we can only move once from the origin. Each iteration, we can move on more. Oh, never mind. Yeah, exactly. That's what I'm thinking, bro. I don't know. Trying to find the smallest possible water level that allows any valid path to exist from start to finish. Oh. Right, so we have a 3 here. We're in the 20s here. Okay, so maybe we have to do like 0, 1, 2, 3, 4, 5, right? And then we have to go to 15, right? And then we're at 15. You know, maybe we can go 14, 13, 12, 11, 10, 12. So the answer is 15. Okay, the answer is 16. Okay, yeah, because... Okay, I understand. I understand what the problem is now. Okay, so what we have to do here is we start from 0, right? And we can go to a 4 directionally adjacent square. And we just have to pretty much keep track of the max, right? So the optimal path here is this way, right? Because we can get to the bottom right within a 4 directionally adjacent matrix. A 4 directionally... We can go and, you know, up, down, left, right. We can't go to 15 because it's 4 directional. No. Yes, you're right. Sorry, I fucked up there, Kendrick. My bad. Yeah. So we have to go to 16. That's why our output is 16 here, right? Because 16 is the largest number that we need to get to. I think that's what T means. So here, obviously, the way to go here would be 0, 1, 3. So we would return. Oh my gosh. Jeez. We would return 3. Oh, I've solved this. Holy fuck. Dude, I don't even remember where I solved this. May 17th. Shit, I've already solved this, dude. Ah. I don't even remember solving it. You're right. Yeah. So I think that's the way to go. So, still a little bit of planning here, right? So, I'm trying to think here. I mean, we could do DFS. We could do BFS, right? Solve it again. Yeah, I mean, I will. So we begin here, right, at 0, 0, right? So I'm thinking we literally just do a BFS, right? But we try every single square, and we just keep track of the max, right? But I guess we'd probably look down here, right? So grid can be is less than n squared. It's like we have to find the minimum max depth path to the bottom corner. Yeah. I mean, so we can either use DFS or BFS, but you know, anyone that watches my stream, I love BFS, dude. That's my favorite. So I mean, we can do DFS. Maybe DFS would probably be the most optimal here. But you know, I love any chance to get a BFS. I just don't know if this will pass. I'm trying to think. BFS just trying every single square, right? And taking the, you know, most optimal path, most minimal path, I guess. But we could also do a DP here, I think, which is kind of crazy because I usually hate DP problems, but I'm trying to think here. You know, maybe... You know, maybe we can do DP, but I don't know. You know, like... So what I'm thinking here, another way to approach this problem, right, is we could do BFS and do every single, you know, try every single way, right? Keep a visited set, right, like what I was saying. But as well, I'm trying to think here, maybe can we do it a better way, right? Can we maybe start at 0, 0, right? I think BFS is the way to do it. Yeah, probably, right? I'm thinking of more of a DP approach here where maybe we can, what we can do here is we can, since we know that we're starting up the top left, right? Maybe what we can do here is obviously we start here, right? We load these numbers here, right? So 1, 2, 3, 4, right? We load these corners here, right? So we do the first row, and then we do our first column here, right? 24, 12, 11, 10, right? And what we can do here is we can then just keep taking the minimum, right? We keep going through the rest of these rows, and we take the minimum, right? So the minimum here is 1, right? The minimum here, sorry, we take the, wait. You see what I'm trying to say here, though? You know, here, the minimum here is 1, right? The minimum here... Oh, shit, no. We probably want to take the maximum, though, right? The maximum here is 24, right? From these two. The maximum here... No, that wouldn't work. Nah, that wouldn't work. I think BFS is probably the way to go. So I think that's probably what we're going to do. I was trying to think of maybe like a DP, a, what do they call it, a bottom-up approach, but... DA3L, dude, what's up, man? Good to see you, bro. I think that's the way we're going to go. We're just going to go with the BFS approach. I'm going to see if it passes. Let me... Okay. So obviously, everyone knows, obviously to do BFS, we need a queue, right? So, think about how we want to do this. Let's grab our res, right? So let's make a res here. Let's do a queue of integers, right? We're going to call it Q, right? Another thing we can do here is we can grab directions here, right? We can make a vector of std pair int. We don't really need std in Leetcode, so let's get rid of that. We can call this our directions array, right? So we can move. We also need a visited array, right? So in our visited array, we need to store the same. I think we're going to need a pair here as well. Right? In the directions array here, we're going to need to store a vector of pairs as well. We're going to call this our... Sorry, not a vector. We want a set. Int. We want std set. We then want, we call this visited, right? Okay. We got all our stuff here, right? We probably want to actually put shit in here, right? So 0, 1, 1, sorry, 1, 0. Trying to think here. Let's do up, down, right, left, right? So our up here would be minus, right? So we would go -1, up, down would be 1. Need our y to be 1, right? Then to go right, we would need to increase, right? So 0, 1, and then sorry, not 0, 1, whoops, 1, 0, -1, 0. Okay. I just want to make sure this is how you define. This is correct for directions. Should I use pair? I'm trying to think std pair or maybe using std tuple. I just never really know what to use. Yeah. How you're indexing. If row call where 0 is the top. Okay, I mean that doesn't really matter, but pair notation, vector. Okay, yeah, this is fine. Okay. Okay, so we got our directions. We have our queue. The first thing we want to do here is, well, actually, do we? I mean, we don't technically have to loop over, right? I was thinking of maybe doing a nested loop here, but I don't think that's necessary, right? Because we know where we're starting from. We know we're starting from the top left corner over here, right? So, you know, we know we're starting from here, right? So, I think it's pretty straightforward. Oh, shit. How do I get this shit off my screen? Right, we're starting from this element here, right? So really all we have to do is we just have to queue our first element, right? Really, I think what we want to keep track of is... Actually, we can use our res to keep track of that. Let's play some music really quick. Okay. Gotta fix the hair. Okay, so what do we want to do here? Well, we have our queue, right? I think we just queue. Let's check like std queue. Can't remember, dude. Is it push back or is it? Let's turn this down a little bit. To push, right? So let's do queue.push, and we can push grid 0, 0, right? We then want to call our BFS function, right? we have our queue, we have our visited, right? So really, honestly, I don't think we have to pass in everything. I think we have everything right in our class here. So we just call our BFS function here. Void BFS, right? Actually, let's put this. This was easier than I thought. Yeah, me too, bro. I thought this was going to be a little bit difficult too, but I think it's easy, kind of straightforward to think about. Pass our queue in here, right? We then do a typical BFS. Maybe, I don't know, maybe this won't pass. I don't know. Maybe it's a time complexity thing that makes it hard. I don't know, but we'll see. So while our queue is not empty, right? Did you learn about priority queue yet? I mean, a little bit. A little bit, bro. I'm not a data structures pro though, so I mean a little bit. Yeah, I have, but you know, I'm not super familiar with it. Is it the same thing or as a queue? Honestly, or priority queue data structure? Yeah, I don't know. Maybe I had to revisit it, but feel free to fucking to explain it or anything. But yeah, we got our queue here, right? What we want to do here? Well, we want to pop, right? So let's do. I mean, it's good for BFS as we reach our optimal lengths when we reach our goal endpoint for first time. Okay, maybe I'll have to like read up on it again. I'm not a data structures pro. I just do the problems. I don't know, but maybe if I want to, I just learned about tries the other day, so that's super useful. I felt pretty smart doing problems with a try. Not gonna lie, but anyway, what do we do? We have something in our queue, right? So we want to pop, right? So we have to do. What's the syntax here? Structured binding. C++. Let's grab this text here. Auto. Trying to think here. Well, actually, we're just pushing a number here, so maybe we might need our row column though. Actually, yeah. So now I'm thinking about it. No, yeah. Now I'm thinking about it. We're gonna have to loop. So for int I is int. Let's do in rows. Yeah, there you go, Kendrick. Yeah, I think that's right, bro. Thank you for that. In rows is equal to grid.size. I think we're gonna need our cols as grid 0 on size. Let me know if maybe there's maybe a better way we can do this, but I'm pretty sure we're gonna need our rows and cols, right? Because then we're not gonna be able to compare and move, right? So let's do row. Less than rows. Sorry. Row is less than rows, row plus plus, right? Need to do the same here for int col 0, col is less than cols, col plus plus, basic loop stuff. I'm trying to think here. Wait, maybe not. Actually, we don't need to loop. What am I thinking? I don't think we do need to loop, right? We would just have to pass BFS, right? We can just pass our row col, right? Being 0, 0. Right? Then we have access to that here. We can just pop here. We can pop auto. What did you have here, Kendrick? Auto row col is equal to q.front. Yeah, is equal to q.front. We should have some game stream where we all can play one day. Yeah, dude. Yeah, I agree. Yeah, I mean, I was thinking about it. What games do you play at it? Yeah. I think we need the first loop as row, but not the whole calls loop. Yeah. Well, no, I feel like all we need is a first element, though, right? Because all we need is a first element. That's where we start, either way, right? So, you know, yeah. So I only think we need the first element, right? Because we only need something just to compare to, right? So we just pass in call. Guess all we need is like int, what do they call this? Let's call this int t, right? I mean, that's what they refer to in the question. Can std pair hold 3 values? This is on hold exactly 2. We need a tuple here then. I have a PS5. I play FIFA or F1 nowadays, but we could play something else too if you have any suggestions. Yeah, I mean, I don't know, dude. I've been playing this game on Steam with my buddy. Well, you're right. It only cares about reaching the bottom right, so we can unmute. Yeah, exactly. What's this game on Steam called? It's called, I'm trying to think. New Valve game. Deadlock, bro. Yeah, I've been playing this game, dude. Yeah, I should try this, dude. It's a good game. I'm playing with Ethan. It's a fire game. I'd be down to play that if you want to at it, yeah. So I'm thinking here now that this is gonna have to change here. We're gonna need a tuple here. We hold an int, an int. Peak. What's peak? I don't know what that is, Kendrick. Is this correct syntax? Yeah, this looks good. Yeah. I used to play for a while. You like it, DA3L? It's kind of fire, bro. Like, it's a good co-op game where you climb with someone. Peak? Is that what you're saying? Oh, Peak on Steam. I've never seen this before. This was kind of interesting, though. This kind of looks like a cartoony version of shit, man. What's that other game called? I'm trying to think, dude. The dude, what's it called? Horror game, Steam. Where you search for loot. Hang on. Yeah, this one, bro. What's this game called? Oh my gosh, dude. I literally cannot even think. Yeah, I'm just gonna click on it.
Hockey is here.
Repo, dude. Repo. Looks like Repo. I know exactly the game you mean. Yeah. Yeah, it's Repo, dude. Grid 00 row call, right? So then we would do, that's what we need a structure binding here. We can call this our element, or our T, sorry. Repo, yes, sir, yes, sir. That's the one. Yeah. That is the one. Row call. Trying to think here. Auto T row call, and then we can do q dot pop, right? And then here, this is where we want to loop through, right? So we would go, okay, so for I think we need another structure binding here for const auto. I don't remember the syntax for this. New row, new call in directions. I don't think this is the proper syntax here. Fix my syntax, dude. What is my syntax? I don't know how to do it. There we go. It was, so I did do it right. Oh my god, I just had square brackets in the for. What am I doing? So we actually need it to be a reference here. So let's fix this, move this over. Deadlock is not released yet? Yeah, it's early access, but I have I got it in the game. So I can invite you guys to the game and you guys can play. If you guys want to play, you just have to give me your Steam ID and stuff and I can invite you. I get invited from a friend, so it's really good though. It's a good game. Yeah, let's get rid of this. Make this go back a little bit. Okay, so full console auto reference. Okay, so we have our new row. Right, our new row and our new call is equal to, let's call this, let's call it d row d call. D row d call. Okay, I will share it to you on Discord. I have to check if my laptop supports it. Yeah, dude. Let me know, dude. I'll be down to invite you. Row call, d call. Okay, so we've created it. We know what our new row and our new call is. So now we need to do an if statement here, right? So we need to check our balance here. So let's do, okay, so for new row, if new row is less than or equal, sorry, is greater than or equal to 0, and new row is, sorry, new call is greater than or equal to 0, and new row is less than rows, which means now I think we have to pass in rows in here, so oh my gosh, dude, bless me, dude. And rows and calls. So we need our rows and our calls. Yep. Okay, so then we do new call is less than calls. And we have another check. We need to make sure that we're not unvisited, right? So and visited dot find new row new call new row new call is equal to visited dot end, right? Shit, we need this here. There we go. So that should check, right? I'm gonna kind of get rid of this. We're gonna make this full screen. I think we know what we're doing. Cool IPFS here. We have q.push, while q, auto t row, q.front, q.pop, for constant directions. New row is less than or equal to 0, is greater than or equal to 0. New row is less than rows. Why do we have a comma here? And new call is less than calls, and visit.find new row new call is equal to visit.end, right? Looks good, right? We would open this up. Now what do we want to do here? Okay, so what we want to do here is we would want to queue up we want to, let's kind of look at our photo here, right? What's the logic here, right? We want to almost always take the lowest element between all of them, right? If we're at 22 or we're at 5, we want to always take the lowest element, right? So how can we do that? How can we think about that? So here, if you would have used a priority queue, the first element in the queue would always be the min T. So when we reach the bottom corner, we just need to return T. Okay. Maybe that might be the optimal approach, bro. I don't know. Trying to think here. Well, we would technically... Maybe we can have like an int min here every time, right? Int min is equal to int max, right? And what we can do here is we can just take the element that we're looking at here, right? So we take like visit nr is equal to nc is equal to true q dot push visited. I mean, yeah, that is right. I mean, I was, yeah, that is correct, yes, but q dot pushback. Let's do that first. Let's push back. It's technically we don't really need this, but I mean, it is what it is. Like, we want new row here, and we want coal. And R is new row, and NC is new coal. Yeah. And R is new row, and grid NR NC is less than or equal to T. Yeah, but I don't think it would be less than or equal to T. That's why I have this min value here that after each iteration when we check the 4 directionally adjacent elements, we take the min value, right? And then we Is that the way is that an interesting way to do it? I mean, we have to add it to visited too, so I guess we can do that as well. So visited is a set. SC set. What is it? Insert. Okay. Visited dot insert. We need to insert 0 here. Now that I think about that, right? So let's insert 0 here. We want row coal. Guess it's really the same thing down here. Insert new row, new coal. Max T grid, new row, new coal, new row, new coal. Right. Well, max T. But the thing is that do we want to take the max value every time, right? I don't feel like we want to take the max value. We want to find the most min value here, right? So as we keep going, we want to find that min value, right? I think we can optimize this a little bit. So I don't know. Maybe I'm thinking about it wrong. I don't know. Isn't your T max of the path? I don't think so, dude. T is just what the element is. T is like yeah, T is the current element, right, that we're looking at. When we pop T, it's just the current element. We're taking the most minimum trip. Pretty much what this question is we're taking we want the most minimum value here all the way to 0. I'm trying to think about the logic in order to do that, right? But yeah, I'm thinking we just want to grab the most minimum value, right? So we come to here, right? And we want the most minimum value, right? I think Adigyar is saying that T needs to be the max of the path to traverse the path. Oh, okay. I think I understand what you're saying. Okay, yeah. So you're saying here. Hang on, I'm confusing myself here. We have our min here, right? Yeah, shit, bro. I'm confusing myself. Yeah, holy fuck. Okay. Let me think about this. So this element here is not grid 0, 0. Think of like how we do the min sum to bottom corner, but change sum with minimum max T and path. Yeah. Grid, new row, new col. Yeah, I'm confusing myself, dude. I'm trying to think about this logically. Q.empty, int min, auto T, row colon Q, Q.pop. So every single T is the actual element that we're looking at, right? Our min is within the 4 directionally adjacent area. We want to take that min, right? So every single min, we want to keep taking that. No, but that won't work. We need a global. That's what. Is that what you guys are saying? We need a global min, right? That's what you're saying. And can't this res be that global min? The min that we've been looking at? Yeah, bro. I cannot wrap my head around how to do this. When moving from row col to new row, new col, the new T in that path is new T is equal to max. But the thing is, like Kendrick, I don't understand why the max. Why would we take the max, right? Because can't we just, if we keep taking the max and we can go to 24, we're going to find the max element in this grid, right? Why would we want it to take the max? That's what I don't get. Or maybe I'm stupid. I don't know. Send me your thought process on Discord, bro. DM it to me, because I think I'm confusing myself. Maybe I seem to overthink a lot of stuff. So. Code or approach? Wait, hang on. Wait. Hang on. The minimum T needed to complete this path is the highest elevation along the path because you have to wait until the water reaches the tallest obstacle. Takes the first example. Why is the answer 3? The answer is 3 because, I mean, we can go 0, 1, 3, right? I mean, we take the minimum here. I mean, why is the answer here? The answer is 16 here because we can go to 4. You can go to 16, right? I mean, this is the most min element that we're looking at here, right? We keep going through. We keep taking the min. The min in this area, so we started 0. The min of 1 and 24 and the 4 directionally adjacent is 1. Okay, the min of 2 and 3 is 2. The min of 3 and 22 and 1, well, we already visited this one, so it doesn't count, is 3. We keep taking the min. That's how I'm thinking about it. You take the max instead of sum because the min time required to reach the end is determined by the max obstacle. I think we're thinking about the problem differently. Like, either I'm totally not fully comprehending the problem, or because I'm thinking about it taking the min of the 4 directionally adjacent area here. That's how I think about it. That's how, is that wrong? Is that wrong for me to think about that? That we just keep taking the min and that's the lowest path? We keep taking the min in the 4 directionally adjacent area and then we make min, we keep moving, right? Does that make sense? Is that wrong, or is that still a correct approach? I don't know. Think if 16 was 100 in the second example, then? Okay, wait. I think I have to explain this in a drawing here. Hang on. I'm going to explain my approach in a drawing. Hang on. I want you guys to tell me if this is wrong thinking, because I'm curious. I actually don't know. This is the way I'm thinking about the problem. I just think we're all thinking about it in different ways, right? So we have 0, 1, 0, 1, 2, 3, 4, right? 24, 12, 11, 10. Okay, let me draw this out really quick. 23, 22, 21, 5, 12, 13, 14, 15, 16, 17, 18, 19, 20, 9, 8, 7, 6. Okay, hear me out here, okay? We start at 0, right? We take the min of the 4 directionally adjacent area that we're talking about, right? Technically, this is invalid, right? Okay, so really we're taking the minimum of these two, right? The minimum here is 1, okay? So then our min, which is my res variable here, right, is now 1, right? We then take the min of these, right? Yeah. Again, this way, this way, this way, and this way. The min here is 2. Right? We then take the min of this way, this way. The min is 3. We then take the min again. 4. Right? You see what I'm trying to get here? We go all the way down. We keep taking the min, right? We get to 5. The min here is 21 and 16, right? We go here, right? Then we take the minimum of what? Here and here, 15. We keep taking the minimum, right? And we keep going. We keep taking the minimum. We're taking the minimum. We're taking the minimum. Boom, boom, boom. And we finally get to here, right? And then we would return 16. Does that make sense? That's how I'm thinking about this. In my head, that's how I think about it. Is that incorrect to think about it like that? One flaw in my approach is I kind of think about, okay, well, we are doing BFS, right? We're adding this node and we're adding this node, right? So then what's the point of doing this check here? Like, what's the point of doing BFS then, right? We're just finding the minimum element, right? I don't know. Is that incorrect? I have no idea. That's my thought process. That was the first thing that came to my head when I thought about solving this. Like, then again, that's kind of more like, I don't know. Can you explain your thought process? Like, maybe send me a message on Discord and I'll put it on the screen. I don't know. Think 4 is 100 instead, and 21 is 5. What would your answer be? Would your answer be wrong? Think 4. So you're saying, okay. Let me get rid of all this. So you're saying 4. It's hard to explain, but if you do new T is equal to max current T grid neighbor, current T is equal to maximum elevation along the path you've taken so far. Grid neighbor is equal to elevation of neighbor cell you want to move into. Hang on, Kendrick. I will get to you. I'll read yours properly in a second. Hang on. Aditya wants me to replace 4. 4 is 100 instead of 20, and 21 is 5. 21 is 5. So 100 and 21 is 5. Okay, so we would obviously we would go 0, 1, 2, 3. We would then go 5, right? We then take the minimum here, right? So the minimum here would be 4 directionally adjacent here, here, and here. We go 5 here again. We go 16. And get to 6, right? And we would return 16. My bad. 22 will be 5. You cannot enter a cell until T value reaches the elevation of a cell, and the time needed to reach the neighbor is equal to the highest elevation you've had to cross along this path, including the neighbor. You cannot enter a cell until T value reaches the elevation of cell. Oh, that's why it's new T is equal. Hang on. Let me ask Claude this. More like max value you can find. Okay. So my approach, okay, look, I know Claude can always be wrong, but that's the way I'm kind of thinking about this problem. The most minimum max value you can find in the path. Right? That's the way that comes in my head. But Kendrick, I feel like your approach is different. Like I just like, I don't know, I'm having trouble explaining, like thinking in my head exactly what you're saying, because I don't understand. You cannot, I'm pretty sure you can enter any cell you want. It's just the most minimum maximal value in the path. Maybe let's implement and check. Okay. Yeah. Okay. All right. Well, I can try and write it formally. Hold up. Your approach. Okay. All right. Let me. I'm having trouble thinking about my approach, though. That's the thing. I'm having trouble thinking about logically how to do this. Like, can DM on Discord? Yeah, you can DM me on Discord. Yeah, that's fine. That works. Maybe also include the code with your approach, Kendrick, because that would also maybe help me like think about what you're trying to say. Let me get my Discord open here. Okay. Let's see here, right? So we have 0, 1, 2, 3, 4, right? We want to... But then again, I don't feel like this is BFS the way I'm doing it. Like, I think I'm thinking about this problem wrong, but that's just like how I automatically think about it in my head. Like, 2, 3, 4, 5. Yeah, I'm not sure how to put this in the code, dude. I don't know how I... In terms of this approach that I already have with this queue. Oh, Kendrick, you sent me a message, bro. You need to wait until the water level reaches the tallest elevation along the path so far, because you cannot cross any cell until the water is at least as high as it. Current maximum elevation on your path is current T, and the neighbor's elevation is grid neighbor. The minimum time to reach that neighbor is therefore UT is equal to... It's cluttery, sorry. Oh, bro. I'm just gonna have a look at how I did it. Like, I'll use a min heap here. Okay. Min heap problem. Diasters plus BFS. Something like this. While Q empty, auto rust is Q front. Min heap is priority queue. Right, okay. Okay, we have our bounty int UT is equal to max TRC grid NRC. Damn, bro, what an interesting problem. Okay, so Kendrick, from what I see here, is you're going through directions, you're creating a new row and a new call. You're then checking the bounds here. You then create a new T is the max of T RC. Grid RC. So are you building a new T? Is this what you're saying? You're building a new... This is a new grid here. UT is less... And this problem's kind of doing my head in, bro, a little bit. T stores the min max evaluation needed to reach cell IJ. Oh, bro, I'm getting a headache now doing this problem, dude. Oh my gosh. Maybe ask Claude to expand on the code. I'm bad at explaining in English. No, it's okay. I think I understand what you're trying to say. Okay, that's what I thought. Okay. You need a min heat priority queue, not a normal queue. Okay. I've never done a min heap in C++, so this is our priority queue, I guess. Tuple int. Doesn't like a min heap like bubble to the top? I can't, dude. I cannot even remember, bro. Like, it's been so long. Dude, I'm getting a stomachache so bad, dude. Oh my gosh. Can you send me your solution added, yeah, bro? Okay, so here we use a priority queue. We have a visited set, directions. We push, visited. Okay, max elevation, PQ pop. If row is equal to n-1, we return that. Okay. For const order reference drdc in directions, new row, new call. If new rows visited on insert, new row, new call. New max elevation is equal to max elevation grid row call, new call. I have to look at this again.
I'm gonna tell you a little story about Bruce Springsteen.
Today we're gonna learn about heaps. You often hear the word heap. Heaps are sometimes called binary heaps and are nearly complete binary trees. Here's an example. I mean that all levels are filled except the lowest, and the lowest level is filled up to a certain point starting from the left. Uses of heaps include heap sort and priority queues. On the left is that the value of the node I is less than or equal to the value of its parent. The value of the node I is greater than or equal to the value of its parent.
See, dude, that's the thing here, bro. Max elevation so far, row call. Can you explain? To make the smallest element come first, use a custom comparator. Okay. Added it on Discord. Okay. Right, so this priority queue here. Let's grab this. Okay. So we have our pair, we have our directions here. So we're doing the same thing here. I mean, we were close. Right, but I think where I was getting stuck is where you need the priority queue part. Also, what I realized here is I need to pass this in as a reference here. Grid. Right. If row is equal to n-1 and col is equal to n-1, and we just return what, res or something. We would just return, right? I mean, it's a void function, right? So yeah, and then we return our res here. I'll take a look in a second at it. Yeah, I tried to do it in DMs. I'm pretty sure you can do it without the priority queue, just more inefficient. I showed it to you in DMs. Okay, I'll take a look, guys, in a second. I'll take a look. The new max elevation is the max of the current path and this cell. We have the res here. We just need to fix this q.push here. We're gonna have some syntax errors here, but I think this needs to be like this. This is Coles, yeah. Okay. Visited. Max. Oh my gosh, dude. We need push here. What do we get here? We got 24. We're not using T here though. What are we missing about this part? T is our max elevation. So oh, I'm still using Q. You're updating the global res, but that doesn't track. Oh, okay. I'm still not understanding this, like, comprehending this fully, though. Like, that's the thing. Like, oh, bro, this problem's frustrating. So I know here that this is a min heap. I think the worst part of DSA is when you're not getting the proof, it makes your brain hurt, and I feel like closing it. Yeah, dude. It's tough, man. That's all part of the process, though, bro. I just don't understand really what this is doing, to be completely honest. Let me take a look at your guys' solutions, dude. This should work without a min heap. Here, I'll try your solution here, Kendrick. Let's see if this passes. Okay, so that passes. So yours, I think you push 3, 2, 1 in your queue, it would be 3, 2, 1, and at priority queue it would be 1, 2, 3. Okay. I'm trying to think about what Kendrick's doing here. Spending way too long on this problem, bro. Like, so Kendrick here has a new vector here of ints. Vector pair of directions is a q pair. T00 is equal to grid 00 q dot push. Right, we pop full auto. We then calculate our new row here and our new call. Check our bounds. How int ut is equal to the max of trc grid nr nc. If ut is less than okay, so I think Kendrick here, this is the way that Kendrick was trying to do it. Was the way I was trying to think about it, I think. Grabbing the max here. We have our ut is less than. I don't know if this will pass, but hey, we'll try it. Okay, so it does pass. Yeah. Yeah, I think you're right, Kendrick. This is the way that I was trying to do it and think about it, but I couldn't figure out the logic in my head. I appreciate this solution, though. I think it's the max check that's confusing you. Yeah. Little frustrating, bro, but I mean, it is what it is, bro. And return res. Pushing our priority queue here, we have our visited, we have our T here. New row, new call. Let's grab this code here. Subtract the max elevation for this path here. Visit on insert. Bro, this is gonna be a bitch to put in here, bro. Oh my gosh. Need a reference. Oh my gosh, dude. Priority queue. C++. Top. Oh, it's top. There we go. I think like max tracks the tallest wall or barricade you've had to cross along a path when you max TRC grid and RC. You make it so the cell knows the min water level required to reach it. Yeah. Appreciate it, guys. I mean that was a tough problem, but it's like I feel like I should have got that, but I mean it is what it is. Sometimes you take the L, so it's like you know, what's different here? A little confused with the syntax here, but let me if the min water level increases, you take the max of the path, but it's weird to think about. Yeah, it definitely is, bro. I should learn patience from you. Yeah, dude. Data being stored. Okay, so really, I mean, we're doing the same thing here. We auto T, we get our last element here, we make res equal to T. New row, new call. Visited.insert, new row, new call. New T is equal to the max of the current T we're looking at, right? Current T in the grid, new row, new call. If you want to really understand it, maybe ask Claude. This explains stepwise how max compute TRC is. Maybe it will help. Yeah. Sometimes I really just gotta deep like think and look at it like. So really with the priority queue here, what's happening here is we're pulling everything to the front, right? Like what Aditya said, right? So our most minimum value is at the front of the queue. Let me think about this. Let me like draw this out. I think this would be good for me. Like, right, so we have our elements here. Okay. Okay. So really what we're doing here is we have our PQ, right? Let's do this as our PQ, right? We start off at 0, right? And we do 0, okay? Our PQ then we look at these two values, right? I can't really see this properly. I have to move this like over here. If you look at it stepwise, it makes so much more sense. I will. I just want to... I'm kind of getting it. Like, I understand the thought process behind it. I think I just, like... I don't know, like... Anyway. So, we calculate here. Okay, this is not unvisited, right? Visited.insert. Insert these two elements. In UT is equal to max T grid new row new col. So the current T we're looking at, right? Our grid new row new col, we want the max, right? Actually, yeah, I'm just gonna ask Claude to step through this. Claude's thinking, dude. Claude's thinking. Thinking hard, dude. Let's maybe ask GPT. Claude's dead, bro. This man GPT's thinking too, dude. It's taking a while for GPT to think as well, man. Bro. While it's thinking, I'm going to... Oh, whoops. Where's Visual Studio? You play any sport now? Oh, GPT gotta say... Yeah, I play pickleball. And I play paddle, if you ever heard of it, padel. I was a tennis player, I'm sure you know that, but yeah, I do a little bit. That's me. Yes, sir, that's you. Push start 0, 0. It's 2. Push 2, 0, 1. Visiting. 1, 0, not visiting. Ordered by the smallest first. Step 3 pop. 2 zeros. So what was... So 1, 0, 0, 2, 0, 1, exponent is 1, 0. It's equal to 3. Okay, I think I understand now. Okay. The only time I have to play is in my office. We play table tennis there. Yeah, I play table tennis too, dude. My dad got me into playing table tennis when I was young. I love table tennis as well, bro. It's a good time. Table tennis. You can give it the specific example too, if that makes better sense to you. No, I think it makes sense to me. I mean, I understand now that we're kind of just using T, right? I think what confused me before was like the max, like what you were saying, but I understand now that T is, you know, our current path that we're looking at, the maximum in our current path, right? And we keep going. We're calculating our new T here, and you know, the priority queue makes it the lowest automatically, so we don't have to keep track of what you were keeping track of, right? You had that if statement here that was keeping track of everything. You know, here, like the min heap just automatically makes the lowest element what we're looking at, right? So I think I understand now. I'm gonna quickly go to the bathroom. I'll be back in a second, and then we're gonna work on a little bit of this. So 1 second. Oh, fuck. I will head to bed. It's 1 here and I've fallen ill. Influenza. Good night, everyone. Good night, Kendrick, dude. Appreciate you being here, bro. It's 4 a.m. here. Yeah, that's crazy, guys. I don't know how you guys stay up so late, bro. Actually, wait. Let's update this. Okay. So I believe here the last time we looked at this, got a terrible design. As chef here loaded, right? So we did this. Host here works. What was the name of the company you got the offer from? I want to check if there's an opening for my sis. Yeah, I'll DM it to you, Added, yeah. Send me a DM on Discord and I'll DM it to you, bro. Table down, empty. Cabron, okay. So we might do a little bit of this manager page here. Kind of think about what we need here. Right now we have everything hard coded here, right? We have our workers here. We have tables. Menu items, worker stuff. That's how we add a new worker. Alice Johnson. We have our menu items. I can't even remember what we're doing here, to be honest. Okay, well, maybe let's probably start with this part here. We can get the workers loaded in here. We can add a new worker. And we can set our tables here, so... Okay, let's get rid of all this hard-coded data. What's up, bro? Got our workers here. Okay, menu items, worker stuff. Let's first of all kind of get this stuff here. So tables and workers both here. We can probably just use this use effect here. Alright, so on load, it loads this here. Okay, right. Fetch from API tables, stores it in the tables, stores this in here. I have to start learning to save money too now. Why is that added? Yeah. Why is that, bro? Let's just see what that does, actually. Oh, well, we're getting an error here. Use effect is not defined. Use effect. Okay, perfect. I don't know why I have this bracket here, bro. What is going on here? Okay. So I don't know why we have brackets here. That's something I spent it on an Apple Watch SE3, which came out. Ooh, let's go, bro. I got an Apple Watch too, dude. I got the Ultra, dude. It's fire. Set workers. What do we got here? Set workers, set tables. Yeah. Okay, this is something that needs to be looked at here. Remove workers. Ultra's too costly for my economy. Oh yeah, I got it as a Christmas gift a couple years ago when it came out. It was pretty pricey, not gonna lie. So what do we got here? We got a worker list. We're passing in the object here. Add worker, remove worker here. Tile here. We map through each worker. Okay, so I think this is where could go wrong here. So I gotta check my database here. So I don't have access to it. I bought it as a self-birthday gift. Let's go, dude. Trying to find my DB schema. Here we go. Okay. Okay, so it looks like here from we store first underscore name, last underscore name. So W first name, W last name, W role. Are you living there? What do you know about Tesla? Like, it's very costly for people there, or a medium price car? I don't know. I think it depends what model you get out of Tesla, but I don't think it's anything super insane or anything. But I think it really just depends on the model of the car. But I think it's cool. I mean, I like Teslas. So. Where is my DB, that's what I'm looking for. So I think here it's taking a workers, add worker, remove worker. What is our remove worker even doing? Set workers. I'm trying to think what we want to do for the remove worker. I wouldn't even know. Grabs uses and tables. I guess we can do a use effect as well. Grab our menu items. Grab menu items. Yep, that looks good. Yeah. Holy shit, dude. Look at all these menu items. I just don't know why we have a bracket here. Wait, a host manager. I'm not sure what we want to do here for this part. Maybe I'll just try and get the tables working, and we can assign a waiter to the table. So assign table, table ID, waiter ID. So on our table list here, t dot number keys equal to t dot ID, table tables dot map keys equal to t dot ID. I think it should be t dot table. No, I don't want this. Stop giving me suggestions. Table t dot number, t dot table, t dot table underscore number, t dot status, t dot assign waiter, score ID, workers dot find WID. Okay, now we got table 1. Pending. Assigned. Has no one assigned. Okay, so it should be assigned to Max, Joshua, right? But here... in India, I can buy a G-Wagon for around the same price as a Tesla Model X. Wow. I'm not really familiar with cars, to be honest, out of here. I'm not super... Wait, okay, so this must be the... Okay, so these are all going to have to be post requests here, right? W role is equal to waiter. I think that's why it's filtering wrong. Yeah, then we have the W roll here, right? Worker.map W. W underscore user underscore ID. Let's tab that. W underscore first name, W underscore last name. Let's get rid of this here. I quit coding. I didn't have enough drive in myself to code. Why not, bro? Why would you quit, dude? Keep grinding, bro. Okay, so I don't know. I still don't know why it's not really giving me. Each child in a list should have a unique key prop. So really this should be in workers, right? w.user_id, w.first_id, w.last_id. How many channels do you have? You mean how many channels do I have? I just have one channel. This one's the only one. I sent an application to a restaurant. I hope I can get my first job. Let's go, bro. Happy for you, man. Okay, so I'm looking at the wrong one. So our workers are working here, right? So for some reason we have 2 Joshua Conrads, though. I don't know why we're getting that, but okay. We need to fix our tables, right? So this is good. We need to fix our table list here. So waiters.map. We're mapping through all the waiters. Let's get rid of this for now. Let's just use workers. Waiters. We want here we go. So now we can choose who to assign. We still don't have our assigned. So we got t.assigned waiter underscore ID. Workers.find w underscore ID is equal. So if our worker ID is equal to a table ID, let's ternary operator here. So right, but table.id doesn't have that. We'd have to. I once saw a channel where you maybe had like 2 videos. Yeah, let's see. Probably. Yeah, this is me when I was in college right here. Long time ago, bro, when I did my persuasive speech here, bro. Yeah, that's probably what you're talking about here. And then this is I was in a fraternity in college too, so this is like a podcast sort of thing. But yeah, the rest of it is just... Yeah. This is me playing tennis too back in the day, bro. 6 years ago, bro. And I was super small, man. I probably weighed like 100 pounds here. Like, so, yeah, there's a little bit of stuff out there on the internet about me, but you're more than welcome to take a look, bro. So I think what we want to do here is we want to go... So we're mapping through the tables here. I'm trying to think here. Maybe we want to map through the workers here. Because assigned waiter ID doesn't have a first name. So we'd have... I was seeing this right now, the tennis one. Yeah, yeah. That was me back in the day, bro. Back in the day when I was pretty young. I think I was like 16 in that, maybe? 17 maybe. I was very small. I'm naturally like super skinny, so trying to think here what's the best way to do this. I think we need to just map through the workers, so grab this here. I remember until second grade, I was a very fast sprinter, always first place because my dog used to run behind me to bite me. That's funny, bro. That's funny. So it looks like here instead we can do so t.assigned ID workers.find w. User underscore ID. Equal to t.assigned waiter underscore ID. Was that? Oh my gosh, that was it. Okay. That was my bug. I thought I'd have to redo it all. Okay. So we got our table here is pending. Our assigned waiters max, right? We can change all our people here. Let's add this remove functionality here. Right, so we have our workers here. Let's add the functionality where we can remove and delete, right? So if we come back over here to our page manager here, we have a remove worker here, right? We just use a filter here. Filter w.id does not equal ID. So it just, I think a filter like gives us a new array, returns the elements of an array. Okay. I'll go to sleep now. When are you finishing the game? I'm gonna work on it tonight, dude. Yeah, I'm gonna work on it tonight. That's the goal. Right after this, I think I'm gonna take a break here in about 20 minutes, make some dinner, eat some dinner, and then start working on the C++ game. So that's the goal. But I want to finish the 2D game in the next 2 weeks so I can start working on 3D stuff in C++ because that'll be really fun. So I'm excited about that. Which weekend are you streaming? I will be streaming in the upcoming weekends here. I will be streaming. Let's take a look at the calendar here. Oh, what is this, dude? Oh my gosh. Calendar 2025. I will be streaming. It's October 6th today, Monday, October 6th. I'm gone this weekend here, so I won't be streaming this weekend, but I will be streaming 17th, 18th, and 19th, and the 20, 24, 25, 26 here. So these 2 weekends I'm free. I'm not going to go see my girlfriend, so I'll be streaming those weekends. hoping I can finish the game by the time we come around to the 17th and 18th, so then I can start some 3D development on stream. Probably be watching a lot of videos and trying to figure out just how to render a block to the screen, but yeah, pretty excited about that. So I'll be streaming. I mean, yeah, once I get back, I'll be streaming every day for probably about 14 days. So pretty exciting. Tony, bro, can I have some food, bro? Let's go, dude. Let's go. Okay. Let's figure out this remove here. So I believe we're gonna have to make a. Let's do delete here. Geez, Copilot's literally so good, dude. Like, okay, so delete users ID, async request, const ID, data error from users. Is that the table we're looking at? Const data error is equal to weight super base from users. Yeah, we delete our ID. Probably don't want to be able to delete now that I think about it, because we're literally deleting a user. So maybe we don't want to be able to do that. So what I'm going to do here, I'm not going to delete actually. I feel like that's kind of stupid. I don't know why that's in here, but page manager. This needs to be looked at. This needs to be looked at. Shouldn't delete roles. How do we shortcut to comment in VS Code? Control slash. Okay. Okay, to add a worker here. So what is this add worker doing? Oh. Worker is not defined. I'll just define it for now. Slash, yeah. Let's just comment this out. So I think it should work now. But it just won't do anything, right? Yeah. Okay, so do we want to add a new worker? Probably don't even want to be able to add a new worker, right? They probably want to be signed up in our system, so. All our workers here are going to be signed up, so. I'm going to leave this here for now because I'm going to get a little bit more clarification about what we want to do here. But yeah, appreciate you guys watching. I'm traveling the first weekend, so maybe the next one I'll be here on your stream. I'll go now. Don't know when I'll come back to your stream next. Sounds good, Brad. Yeah, see you later. I'm going to end the stream here, guys. I'm going to eat some dinner and work a little bit on my C++ game, but probably need a little bit more clarification on what exactly we want to do here. But yeah, I'll be back at it